the whole reason we do derivatives of inverses is because if we don't do this, then we can't talk about derivatives of log and exponential functions.
We're going to be talking about those too?
Yeah.
Oh.
It'll be like the best thing we've ever done. So basically, the gist of it is, so if you're asked to find f inverse, the derivative of this is going to be basically 1 over the derivative of the original function. So I left that a blank spot because we have to figure out what value that we put into the original function produced that answer. Okay? So if you're asked to find, say, the derivative of our inverse at A is the answer, A is the y value, then what we have to do is find the derivative of whatever B was. B is the value that produced A. So in my original function, whatever it is, if I put in B, A comes out. So if I'm asked to find the derivative evaluated at A of my inverse, then I have to figure out what x value produced that. So if we go down to our first example down here, ignoring all that, ignoring that, we're going to go down, we're going to do those in a minute. If I'm looking at my first example right here, I'm asked to find the f inverse of these. So if I'm asked to find f inverse derivative, so f, the derivative dx of f inverse of my A value, the first thing I do is figure out what B is. So the first thing I do is set my function equal to what A was and solve. That's what I have to do. And so the first thing I have to do is I have to find out what input gave me A out. I have to find that first. So I have, this first one is x squared plus 3x plus 2. And the important part is that they're telling me it has to be greater than -3/2. And the reason they're telling me that is that's where the vertex is. That's the cut at the vertex to ensure it's a one-to-one function. And they want to know at A equals 2. So what I do is I set that function equal to 2 and I solve. So I have x squared plus 3x plus 2 is equal to 2. And now I need to solve for x. What value did I put in there to get that out? So it's a quadratic, so I bring everything to the left-hand side, and I get x squared plus 3x is equal to 0. Right? Is equal to 0? Okay, so now I'm going to factor it. I'm not going to use a quadratic. I have two terms. Greatest common factor is x, so I factor out an x, leaving me x plus 3. So if I put 0 into the original function, 2 will come out. That comes from this one. So if I put x is 0 into the original function, 2 should come out. And if I put in -3 into the original function, 2 should also come out. I have found the value that I would have put in to get 2 out. Because of the fact that we are restricted at x is greater than or equal to -3/2, am I going to use the -3? No, that's actually on the left side of this vertex, so I'm not going to use it because that's on the left side of my vertex. And I had to cut my vertex. I had to cut it at my vertex so it is ensuring 1-to-1. So after I've found the x value that produced 2, this is the b, the next thing I'm going to do is just find my derivative.
Wait a second. Why did you have to cut the vertex again?
Okay, I'll show you. So I'm going to find f prime of x. All parabolic shapes, the question was, why did I have to cut it at the vertex? Well, all parabolic shapes without a transformation look like this. That is not a one-to-one function. to ensure that it's a one-to-one function, then I have to cut it at the vertex. So it passes both the horizontal and vertical line test to make it one-to-one. If it's not one-to-one, it will not have an inverse. So it's cut at the vertex. Now this is telling you, right here, this is actually telling you where it is. Oh, that didn't work.
So what you mean to say is that it has to pass both tests.
So it's actually telling us right here. So you don't have to do that extra work. You don't have to do the extra work, it's telling you. So you don't have to find the vertex. So after you have found the value that produces that value A, the x that you put in to get the answer of 2, then you find your derivative of your original function. So my original function, again, is equal to x squared plus 3x plus 2. The derivative of this is what? The derivative is the last part. The last part I have to do is d dx of f inverse of x is equal to 1 over the derivative of my function evaluated at my inverse. And we don't want to have to do all that work. For us, they're asking us d dx of f inverse of an answer of 2. So this is going to be equal to 1 over the derivative of what I put into it to get to. So in other words, I put in 0, so I'm going to evaluate my derivative at 0. So this is going to be equal to 1 over 2 multiplied by 0 plus 3. So what is my derivative? 1 over 3. And that's it. Better? Worse? Better? All right, so we'll do the tangent in a minute. Try this one. And I want the f inverse, the derivative of f inverse evaluated at 2. Give it a go. Actually, let me just write this over here. So how far, Vicki, how far did you need me to go back to?
Oh, no, I'm
How far, so the steps, how far did you need me to show you? What do you all need?
just bottom.
Just the bottom part?
Yeah, that's it.
Just that part?
Yeah.
And what was the function? Somebody have it on their notes? So the function that you all are working on is f of x is equal to x plus the square root of x. Evaluated at what? A equals 2. A is your output. So go ahead and do that, same steps. Okay, so here's all your pre-calc 1 that you all forgot, which is cool. It's all good. It's all good. So the first thing I'm going to do is find x plus the square root of x is equal to 2. It's the first thing we do. I need to find what x produced that. Now the answer is 1. It's the only way it's going to work is 1. But let's go through it. How do I know it's 1? Well, the only thing that I put in for x that's going to work is 1. But we're going to go through it. So the square root of x is equal to 2 minus x. Get the square root by itself, isolate it. I'm going to square both sides. And when I square both sides, I get x is equal to 4 minus 4x plus x squared. I'm going to bring x to the other side and reorder it. So I've got 0 is equal to x squared minus 5x plus 4. And then I refactor it. And so 0 is equal to x minus 4 and x minus 1. So x is equal to 4 and 1. Now this one I didn't have, on my other one I didn't have to check it. I just had to pay attention to my domain, but I have to check this one because I'm getting 2 answers. If I'm getting 2 answers, one of these isn't going to work because this is guaranteed to be 1-to-1 if I have an inverse. And this is 1-to-1. So one of these doesn't check. And that's because I can't have a y associated to 2 x's for it to be 1-to-1. It has to pass a horizontal line test. So I check these both back into this. If I put 4 in, does 4 plus the square root of 4 equal 2? No. So even though I got an answer here, it's not a true answer, it's extraneous. So it isn't going to be a part of what I'm looking for. So the only one I have is 1. Okay? So once I found this, which is what I was chasing in the first place, what is my next step? Find the derivative of my original function. So the second thing I'm going to do is find the derivative of my original function. My original function was x plus the square root of x. So I'm going to find the original function and derivative. So f prime is equal to 1 plus 1/2 x raised to the negative 1/2. Now the last thing I do is put it into that form, which is d dx of my inverse evaluated at a, which happened to be, what was it, 2? Is equal to 1 over the derivative of my function evaluated at 1. Evaluated at 1, because that was the x value that produced 2. So this is going to be equal to 1 over 1 plus 1/2, and then 1 raised to the negative 1/2, so the square root of 1, which is just 1. So this is equal to 1 over 3/2. 1 plus 1/2 is 3/2. So my final answer is 2 over 3. How was that? Better than yesterday? Cool. Good. Okay. Yes?
We had 4 plus square root of 4. You have to take into account the negative square root.
So if we have 4 plus the square root of 4?
Yeah,
No, no, because it's not in the original function. The plus and minus is not in the original function, so no. Yeah, good question. All right, we're going to go back to our trig functions, and I'm going to make my life and your life easier. I'm going to rewrite these because I love you all, to make your life easier. So these are in terms of x, so I'm going to write it in terms of u. So the derivative with respect to u of sine inverse u is equal to 1 over the square root of 1 minus u squared multiplied by u prime by the chain rule. So if your angle is not x, you better multiply by the derivative of your angle. The other one, for cosine, d du, of the cosine inverse of u is going to be negative 1 over the square root of 1 minus u squared, the derivative of u. So if your angle is not 1, by the chain rule, you better make sure that you are multiplying by the derivative of that angle. I'm going to do it for all of them. The derivative of tangent with respect to u, of tangent inverse of u, is going to be 1 over 1 plus u squared and the derivative of u. So if your angle is not x. Yes? Yep, these are all multiplied by u. And cotangent inverse, cosecant inverse, secant inverse. So d du of the cotangent inverse of u, negative 1 over 1 plus u squared multiplied by the derivative of u. So these are the ones you'd put on your note card. And then our cosecant, or secant here, so derivative of the secant of u is 1 over the absolute value of u squared minus 1, derivative of u. Yes? It's cotangent. Thank you. Look at that magic of marker. And power of grayskull. The derivative of u, cosecant inverse of u, is equal to negative 1 over the absolute value of u, the square root of u squared minus 1 times the derivative of u. So if your angle is not x, if your angle is not theta, if your angle is not a linear, then you have to do the chain rule. Give you a moment to write all those down, and then we're going to do some derivatives, and then we're going to go into the next section. And there's only 9 questions on this. There's only 9. No, on this homework. No. And so because Vicky asked, and we just love Vicky the best, the test will be probably Wednesday or Thursday next week. Actually, it has nothing to do with Vicky. It's just our time. It'll be Wednesday or Thursday of next week.
No, you can give me the credit. I'm fine. I'm fine with the credit.
Okay. So the reason we need all of that is because we're going to come down and do the derivative of the tangent. We're just going to do the derivative right out. So let me just erase this because we just want to be able to do the derivative. Oh, I didn't want to do that one. I wanted to do this. Okay. So if I'm asked to find the derivative, I'm just going to do this over here. If I'm asked to find, do I have any down here? I do have some down here. Look at that. Let's do A. So let's do the derivative of A. So y prime is equal to, my u is x squared. Okay? So wherever I see u on those examples that I had before, I'm going to replace it with x squared. But I still need to find the derivative of this. So the derivative, or u prime, is 2x. So I got to remember once I put u, or in other words, x squared in that formula, that I have to multiply by 2x. Okay? So the derivative of sine inverse, what is the derivative of sine inverse? You all wrote it down. I'd have to scroll back up. It's one I don't know off the top of my head.
1 over
The square root of 1 minus u squared. So 1 minus, and then what is my u again? X squared. So it's 1 minus x squared squared. Multiplied by the derivative of u, which is 2x. Oh, yeah, and I need a squared on there. Thank you. Let me erase that. I told you to do it, and then I didn't do it. Sketchy today. Not as bad as yesterday, though. X squared squared. All right, so just to clean this up a little bit, not too bad of a cleanup, it's just 2x over the square root of 1 minus x to the 4th. How is that? Not too bad? Okay, now let's do the next one because it's interesting and fun. It is interesting and fun. So on this one I have, my angle is just linear, so I don't have to worry about multiplying by the derivative of x because it's just going to be 1. But I do have to use the chain rule here. So this is u. U is going to be equal to 1 plus the tangent inverse of x. That's what u is. I don't have to worry about the angle because my angle is linear, so I don't have to do what I did on my previous example. My angle is linear. That means u cubed is equal to 1 plus the tangent inverse of x cubed. The derivative with respect to u cubed is going to be 3u squared u prime by the chain rule. So what do I have to find still? I don't have to find u squared. I know what u is. I can just, when I see u squared, I can just replace it with 1 plus the tangent inverse of x. I need to find the derivative of u. So I need to do the derivative of 1 plus the tangent inverse. What's the derivative of 1? 0. So u prime is equal to, and I go and look at my formulas, and what is the formula for the tangent inverse derivative?
1 over 1 plus x squared.
So with that information, y prime is equal to 3 multiplied by 1 plus the tangent inverse of x squared times the derivative we just found, which is 1 over 1 plus x squared. This is the derivative of u prime. So cleaning this up, I get 3, you don't have to multiply it through, 1 plus the tangent inverse of x squared all over 1 plus x squared. You don't have to multiply the 3 through if you don't want to. Yes?
How do you know this is linear?
Is that linear? Okay. It's all good. Happens to all of us. Welcome to calculus. Happens to all of us. It's all good. It's all good. It's all good. Okay. Which one of these lovelies would you like to do? C or D? C. Okay, cool. You can do C. Then cool. That's okay too. Confusion is okay. So if you chose C, then you're going to do the derivative with a chain rule. So the first thing is you're going to think of this as u to the negative 1, right? So if you think of this as u to the negative 1, then the derivative with respect to u of u to the negative 1 will be negative u to the negative 2 multiplied by the derivative of u, if that's the one you chose. And so if you chose that one, then this is going to be negative the tangent inverse of x raised to the negative 2, and then multiplied by the derivative of the tangent inverse, which is 1 over, is it 1 plus x squared. So if you chose that one, then that would be your derivative. Now let's just clean this up. It is going to be negative 1 over 1 plus x squared multiplied by the tangent inverse of x, the quantity squared. Just making a positive exponent. That's all I did. So if you did that one.
So you just took the numerator and get the positive.
Yeah, because it's a negative exponent to begin with. So I just brought it down, and then I basically have negative 1 times 1. That's where the negative 1 came from, the numerator.
Are you going to want us to do that every time?
No, it's a good idea to get comfortable with it, though. Okay, now if you chose this one, you do have to do the product rule within the chain rule. So you're going to first find the derivative of this. So we're going to do the product rule. So this is u, so then u prime is going to be 1 over, it's a negative 1 over, and is it 1 minus, or my angle squared? Is it 1, you're all looking on yours? So 1 minus my angle squared, multiplied by the derivative of my angle. Well, what's the derivative of 2x? Just 2. And then this is v, so then v prime is going to be, so the derivative of sine inverse is going to be 1, positive 1 over the square root, and that should be squared back here. 1 minus my angle, 1 minus my angle squared times the derivative of my angle. Well, what's the derivative again? 2. So now all I have to do is this is going to equal, so y prime is going to equal u prime v plus v prime u. So this will equal, for this example, is going to equal negative 2 multiplied by the sine inverse of 2x divided by 1 minus 2x quantity squared, or you can put 4x squared, that's fine. And then plus 2 the cosine inverse of 2x all over 1 minus 2x, the quantity squared. Because they have the same denominator, I'm going to put them over the same denominator. And so this is going to equal negative 2 sine inverse of 2x plus 2, the cosine inverse of 2x, all over the square root of 1 minus 4x squared. And that is my final answer. How was that? It's long. It's calculus. You all are going to go into fields of study, unless you're a math teacher like me. You're all going into fields of study in which you're going to be paid very, very well. So the pain and misery that you're in right now is going to pay off in the long run, unless you go into teaching. Sorry, Bryce. It's never going to pay off, but you're going to enjoy your job. You're never going to make a lot of money, but you're going to really love your life.
It's the little things.
It's the little things in life.